Hello everybody and welcome to Mrs. Baker's Monster Paper Walkthroughs. This is Module 10, which is the Metals module, and it is question 8. So magnesium, calcium and strontium are all group 2 elements. Complete the table to show the arrangements of electrons in a calcium atom. So because they're in group 2, we know they must have 2 electrons in their outer shell, and then we're going to just use the parking analogy of 2, 8, 8 to complete the calcium atom. Describe how the arrangement of electrons in a strontium atom is similar to the arrangements of an electron in a calcium atom. Well, this is all to do with periods. So we've got calcium, which is in period 4, and strontium, which is in period 5. Well, the period number tells us the amount of shells that it has, and the group number tells us the amount of outermost shells or valence electrons that it has. So then the valence electrons are similar, so we can have same number of valence electrons, and then we can quantify that, which is 2. They're different because calcium has 4 energy shells, but strontium has 5 energy shells. Calcium reacts with cold water to form 2 products. The colorless gas P, which pops with a lighted splint, and a weakly alkaline solution Q, which turns milky when carbon dioxide is bubbled through it. So gas P, anything that pops with a lighted splint, must be hydrogen. That is the chemical test for hydrogen. Identify the ion responsible for making the solution alkaline. Well, we know that all alkaline solutions are OH minus ions, and all acidic solutions contain H plus. Suggest the pH of Q. Well, because it's weakly alkaline, we know it's going to be somewhere more than 7, but it can't be anything more than around about 12. So because it says suggest, it wants us to pick an actual number. So anywhere between 7 and 12, you're going to get the mark. I would put 11. Write a chemical equation for the reaction of calcium with cold water. Well, we know that any metal reacting with cold water will make a metal hydroxide and hydrogen gas. So it says chemical equation, therefore we know we need to use symbols. So we've got calcium, and we are reacting it with water, and we are going to make calcium hydroxide, and we're going to make hydrogen gas. And then we just need to balance that. So we know over here we've got 2 times 1, which is 2, and we've got another 2 here. So we've got 4 hydrogen atoms, which means we need 4 hydrogen atoms on the left. And then we've got 2 oxygens over here. Well, that's okay because we've already got 2 oxygens. We've got 1 calcium here and we've got 1 calcium here, so it is actually balanced. Let's have a little look at why calcium hydroxide is written the way it is. Don't forget that calcium is in group 2, so it's a +2. Each hydroxide we know is OH1 minus. So we need this to react in a 1:2 ratio because we need 2 hydroxides. And the reason why we put it in brackets is because if we put calcium hydroxide like this and we said we want 2 hydroxides, this is actually 1 calcium, 1 oxygen, and 2 hydrogens, and that's no good for us. We need it to say 1 calcium and then our hydroxides, but we need to keep the hydroxides together and double them. That's why we put it in brackets. So magnesium reacts with chlorine to form magnesium chloride, or MgCl2. Magnesium chloride is an ionic compound. Complete the diagrams to show the electronic structures of the ions in magnesium chloride and show the charges. Okay, so chloride is in group 7, so it's going to form a -1 ion. Magnesium is in group 2, so it's going to form a 2+ ion. It doesn't matter which way around you do it. You can do +2 or 2 plus, doesn't matter. And chloride is also going to be -1 on this side. So if we consult our periodic table, we can see that chlorine is actually in period 3. So it's going to gain an extra electron and become like argon, which is the noble gas at the end of period 3. Remember that non-metals jump forward to achieve the electronic structure of the noble gas that is in the same period as them. So because it's in period 3, it needs 3 full outer shells. So we must add the outer shell of both chloride ions. We'll do these at the same time. Now we know that chloride has 1, 2, 3, 4, 5, 6, 7 of its own in its outer shell, and it's picked up 1 from the magnesium. And again, this one also the same, 7 in its outer shell, and it's picked up 1 from the magnesium. Don't worry about where you put those X's, it really doesn't matter. Magnesium is actually in period 3 itself, but remember that the non-metals, they give away electrons, the metals, sorry, give away electrons and jump backwards to achieve the noble gas electronic structure of the noble gas that's in the period before it, because they're emptying their outer shell electron. So because magnesium started in period 3, it's going to end up with a noble gas configuration of neon, which is in period 2, 1 before it, so it only needs 2 shells. What we'll do then is we will say it's got a full outer shell of all of the electrons that originally belonged to itself, and you can see that it's given these 2 electrons away here to the chloride ions. Give 3 physical properties that are typical of ionic compounds, such as magnesium chloride. So we're looking for three properties and 3 physical properties. So things that can be measured without a chemical reaction. So the most obvious ones would be high melting and boiling points. And remember, please don't be lazy and write MP and BP because the examiner won't know what you're talking about. But it's that strong electrostatic attraction gives them a high melting and boiling point. They are all soluble in water because remember, water is a polar substance that's able to overcome the electrostatic attraction. And don't forget that they conduct electricity, but only when molten or dissolved. We know they do not conduct electricity when they are solid because there is no way for the ions to move. They're fixed in position. Aqueous magnesium chloride is added to aqueous silver nitrate. A white precipitate forms. Write an ionic equation for this reaction and include state symbols. So because it says include state symbols, we know we're getting a mark for it. So in this case, magnesium chloride is added to silver nitrate, and we know that the precipitate of silver chloride forms. This we remember from our chemical tests because we know that silver nitrate is the chemical test for all of the halogens, chloride, bromide, and iodide. And we know that as we go down the group, the colors that we get darker. So we've got a white precipitate for chloride, we have a cream precipitate for bromide, and we have a yellow precipitate for iodide. This is only asking us about chloride. So if you're asked to write a precipitation reaction, then it's a gift from the chemistry gods because you don't even have to worry about what's changed oxidation state or anything like that. All you have to do as soon as you see the word precipitate and you're writing an ionic equation, you write the symbol or the formula for the precipitate that was formed. In this case, we know it's silver chloride. And we know that it's a 1-to-1 ratio because silver always forms +1 ions and chloride always forms 1 negative ions. So it's silver chloride, and we know that because it's a precipitate, it must be a solid. And then we're going to write the arrow, and we're just going to write the ions that make it up. So in this case, Silver chloride is made up of Ag plus and Cl minus. These are both in aqueous form. We know that they're in aqueous form because it told us aqueous magnesium chloride and aqueous silver nitrate. So that's our correct answer. 2 marks.